Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Strength of Materials in 6. The topic of this tutorial is a mixed bag of possible exam questions. Round 5, question 1. The formulas used are included in the video. The question is also posted in the description box below. We have been asked to issue a cautionary note. Some of the formulas used in these videos, which are taken from DP examinations and past papers, do not appear in most textbooks or the formula sheet attached to your exam. You will need to know them in order to do some of the sums. They appear in the beginning and end screens. Let's get straight into it. Our question states, a hot rolled H profile 203 by 203 by 86.4 kgs per meter is used as a cantilever. It supports a uniformly distributed load of 4 kilonewtons per meter over the full length, as well as a concentrated load of 10 kilonewtons at the free end. The maximum allowed bending stress in the beam is 100 megapascals. The slope is limited to 1 times 10 to the negative 3 of the length, radians, in terms of its length. Assume E is modulus of elasticity is 200 gigapascals. Negate the weight of the beam. And they ask you to calculate the following. The maximum allowed length of the beam, state your reason. The maximum slope, deflection and bending stress for the allowed length, and also the force in a prop at the free end for no resultant deflection. Okay, first things first. We need to calculate M. So M, the maximum allowed length. So we need M. Our data is an H profile 203 by 203 by 86.4 kg per meter. And it supports a uniformly distributed load, UDL, at 4 kilonewtons per meter, 4 kilonewtons per meter. A point load at 10 kilonewton. Point load is 10 kilonewtons. And the maximum bending stress, so stress bending, is equal to 100 times 10 to the 6 pascals. And the slope is this, is equal to 1 times 10 to the negative 3 per length. Radians, and finally our E equals 200 times 10 to the 9 pascals. Okay, now what we need to do is state M equals stress times Z. Now Z you will get in your hot rolled tables. Z is always found in your hot rolled tables. So look in your hot rolled tables for your Z, X, X. We only deal in XX when we deal with this. We never deal in YY, we always deal in XX. So whatever value they say, so if it's I, if it's Z, if it's I, if it's h or whatever, we always deal with x. So now that's z, so this equals 100 times 10 to the 6 times 851,3 times 10 to the minus 6. This equals now 85120 megameters. Now m will be important later, so 85120 times 10 to the 6 meters. Okay, so m equals WL over 2 WL squared plus WL. So we don't have L. We have both W's, but we don't have L. So both W's. So this is 4 times 10 to the 3 L squared over 2 85120 over L divided by 2 plus 10 times 10 to the 3 L. Okay, so what we're going to do now is say, now we're going to bring this all, we can say this is over 1. So what we can do is say this, so 85120 minus 10 times 10 to the 3 L equals 4 times 10 to the 3 L squared over 2. Right, so now we would take this whole thing and multiply it by 2. Then what we do is we take this 4 and we divide it by 4 times 10 to the 3 and square root that. Then we're left with L. We're left with L on the one side. So then we work all this out. We work all this out and then we get L. So let's work it out quickly. Then what we will do is have L so then we'll have 6,128 L equals L. So we want L by itself, as I will take this divided by 1. So divided by itself, and we get, take that divided by itself, we get L equals 4,486 meters. So L equals 4,486 meters. Next question. They want the maximum slope, deflection and bending stress for the allowed length. So that length is very important. So what we want first is the slope. So equals WL3 over 6EI plus WL2 over 2EI. So, first things first. We've got our slope, so now we have 4 times 10 to the 3 times 4,486 to the 3 all over 6 times 200 times 10 to the 9 times. Now this is where, this is 94,61 times 10 to the minus 6 plus, now this is our deflection. So our deflection is 1 times 10 to the minus 3 per length, per unit length. So we want L. So all this stays the same, and we're left with L cubed. Right, so plus 10 times 10 to the 3, L squared over 2 times 200 times 10 to the 9 times 94,61 times 10 to the minus 6. If you can't see this one over here, it's exactly the same from here, only that 6 changes to a 2, but everything else is exactly the same. Alright, so we put this in our calculator and we get two numbers, which I will give you now. Equals 1 times 10 to the minus 3 equals 35,232 times 10 to the minus 6 L cubed plus, okay, next part of it is 264,242 times 10 to the minus 6 L squared. Now what we need to do is take both of these numbers, we take this over to here. So 1 times 10 to the minus 3 minus 264,242 times 10 to the minus 6 L squared equals 35,232 times 10 to the minus 6 L cubed. What you can do now is take L2 and divide it there, because these two numbers will come into play. So you can take this L squared and divide by L squared. So that becomes an L. So it becomes regular L now. And L squared goes away. So we've got L. Now all that remains is put all this together, and L equals 2,765 meters. So that is the length that suits both of our limits. That is the length that suits both our limits. So the length that suits both our limits is 2,765 meters. Okay, next, what we want is the slope, deflection, and bending stress. So we're going to do the slope for the required, for the allowed length. So slope, WL cubed over 6 EI plus WL squared over 2 EI. Okay, so what we have here is 4 times 10 to the 3 times 2,765 cubed over 6 times 10 times 200 times 10 to the 9 times 94,61 times 10 to the minus 6 plus 10 times 10 to the 3 times 2,765 squared over 2 times 200 times 10 to the 9 times 94,61 times 10 to the minus 6. Now put that all in your calculator, and our slope is 2,765 times 10 to the minus 3 radians. Okay, that's our slope. Next is what we're going to do. So deflection equals W L to the power 4 8 EI plus WL3 over 3 EI. So this is 4 times 10 to the 3 times 2,765 to the power 4 over 8 times 200 times 10 to the 9 times 94,61 times 10 to the minus 6 plus 10 times 10 to the 3 times 2,765 to the power 3 all over 3 times 200 times 10 to the 9 times 94,61 times 10 to the minus 6. Put that in your calculator, and we are left with 5,268 millimeters. Okay, so M equals, now W is 4 times 10 to the 3 times 2,765 squared over 2 plus 10 times 10 to the 3 times 2,765. And M equals 42940 Newton meters. Okay, so M equals 42940 Newton meters. Alright, now our bending stress. Now we need our stress. So stress equals M over Z equals stress equals 42940 over 851,2 times 10 to the minus 6 equals 50,447 megapascals. In our previous answer, we got, now they want the force of a thing to require no deflection. So it is deflection equals FL power cubed over 3 EI. So our deflection is 5,268 times 10 to the minus 3 equals F times 2,765 cubed all over 3 times 200 times 10 to the 9 times I 94,61 times 10 to the minus 6. Now to make F the subject of the formula, you bring all this up here and take that down there. Okay, so all we need to do now is take 5,268 times 10 to the minus 3 times 3 times 200 times 10 to the 9 times 94,61 times 10 to the minus 6 all over 2,765 cubed equals F. So now finally F equals 39,115 kilonewtons. That's the force of the prop that'll get it exactly to have no deflection. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.